G'day. I thought I'd be making one video about scraping in this XY table, but from looking at the stuff I've already done, it could take a bit more than one. So this one is about the dovetails, the angles. Previous one was just doing the flat surfaces. I'm going to try and keep this one short so that you don't get the full hours upon hours of me scraping away at bits of cast iron and just sort of show you the high points, but we'll see how we go with this one. Having scraped my intermediate piece flat and parallel, I'm now looking at the base. I could look at the top piece, but the base was just, well, appealing. Now you can see here I've blued up the dovetail here, or the surface here, and run that in here. Don't worry about the bit in the back because that's still painted. I need to make up a special dovetail to do that. But what I want to do now is get this surface flat, and you can see that I've got blue has transferred here and a little bit here, but most of it hasn't, right? And this is the matching part and it bears that out. So I need to get my scraper in and actually scrape that down. Looking on the other side, it's a similar sort of situation. There's not nice even distribution of blue. It's all you know, lumpy, stripy, all that sort of thing, which shows that this is you know, once again the machine surface, and it's not terribly precisely machined. Still working on the base dovetails. You can see I've got a bit of blue here now, but it's fading out towards the end here, so this is high and that's not. The other side is a bit more uniform, as in it goes from about there to there. So it's a matter of, once again, scraping down the high spots. One of the problems I've got here is that the dovetail was cut with a cutter, and they didn't quite get the height of the cutter and the height of this section the same. And so there was a lip in there, and that's what was causing that sort of narrow strip at the front of the flat on the concave dovetail. So I've had to take that off. This one's still got a little bit there, but that's okay because the dovetail here has got the gib against it. This one here needs a sharp corner, and so I'll have to try and clear that out. I may end up attacking that with an angle grinder and just very, very carefully grinding out the base of that V, just to make sure I've got clearance. That's a 60-degree angle in there, and to get that precisely 60 degrees and to get the corresponding slide precisely at 60, I'm going to have to make up a 60-degree, what would you call it, scraping guide, I guess. This started off as a piece of round bar, just because I didn't have any rectangular stock of a suitable size. I've set up on my gaff blocks, trammed these in so they're parallel, and then trammed this in so that the top surface here is you know, parallel too. And so I'm going to run across with a cutter and then just put a 60-degree bevel on that. I'm still going to have to come back and scrape that, and you know, do all the fun things, but that'll get me started. This is my dovetail spotting gauge. I've just done a bit of a rough break-up pass on the top surface here. You might just be able to pick up the marks from the tooling. So that's just basically to break that up. I'm going to try that in the plate in a moment and just see how flat that is. I want to get this surface flat, I want to get this surface flat and at 60 degrees. I've tried it with my best protractor with a vernier scale, and it seems to be a 60-degree thing, so that's good. It doesn't actually matter too much because I'm going to be using this to spot the base and make sure the base and the top are all right, and then using those to do the concave dovetails. As long as everything matches, it's okay, but I need this to do basically the base and the top on those convex dovetails to make sure that that's all good. And one side more than the other, because the other side with the gib strip on it will tend to self-center. So I really only need to do one side of each of those, you know, scrupulously. To hold this is a bit too long. It's just a shy of 200 millimeters. I've got out my split vise, free vise, gack vise, whatever you want to call it. These are actually available, shameless plug here, these are actually available from Hemingway Kits in the UK. I actually designed this and sold them the patterns, so they will quite happily sell you the castings, which you can make up, but it is handy for this sort of thing. So I can use the mill table. The height is adjustable, which is really nice, and clamp this in even though it's long, and I'll have a part that's firmly held so I can scrape it properly. I can even use the mill light a little bit here to help illuminate the part. Some of you may be asking, well, how do you do this scraping thing anyway? And I'm not sure I'm the best person to tell you because I'm relatively new at it, but to put it in simple terms, I have a piece of cast iron. I've got a very flat surface in the surface plate, and I've got a very thin layer of blue on there, bearing blue, engineer's blue, whatever you want to call it, as long as it stays wet. I've taken this surface and I've rubbed it on there to transfer some blue, and what's going to happen is the high spots, which you can see here with the blue on them, will pick up the blue. The low spots won't. Now, to get an idea of how thick the layer of blue on the plate is, you might just be able to pick up, there's still some very slight machining marks. So basically, I've yet to break through the machined finish on this. I'm not going to bother because I don't need to. I'm only making this surface flat so that when I put it on the mating surface, I'm not going to have the problem with it. It'll rock around and wobble and all that sort of thing, give me false readings. And then it's a matter of basically using the scraper with just a short motion to remove a little bit of the blue. When you first start out and you have blue down one end and nothing down here and then a spot there or something, you generally scrape it all over, and you can use quite long strokes. But when you're doing, trying to get the fit properly, we talk about spots per square inch. So if you can imagine a square inch and how many spots you've got in there, that's how it's measured. And depending, the best book to probably read is Connelly, called Machine Tool Reconditioning. I'll try and remember to put a link down below. But what I would now be doing with this is coming through and saying, well, there's some big blobby bits there. I'm going to just sort of scrape a little bit in the middle and try and break them up. Okay, I've got relatively uniform blue here. You could possibly say it's lacking a little bit through there, but it's not too bad, and it's certainly good enough for what I want to do. But if I break those up, I should be able to get, lots of little spots everywhere, which would be perfectly adequate. Now, because this depends on the plate and the person doing it and the direction you wobble it and all that sort of thing, I do it this way, someone else does it, they'll get a different result, but the end result should be round about the same number of spots per inch. Now, that's basically it. When you're wiping this or when you're rubbing this on the plate, you're only going maybe 1/8 of an inch just to transfer that blue on, and then just picking off the high spots. A lot of scraping is about being able to read the pattern that the blue gives you. And so here what I'm doing is I've got the mating part and I've blued up the tops of the dovetails there, and I'm using that to spot onto this part. And I've outlined it in black texture because it's a little bit hard to see, but you can see there's a big high spot there, there's a little spot up the top there, and there's a couple of spots just down in here. And on this side I've got another high spot here and there and there, so they're holding that up. So I don't want to touch that because I've done all my scraping on that, so the only thing left to me is basically to continue scraping on these and take off these high spots. And I think it's basically a manufacturing error. I think it's the cutter hasn't been set right or something like that, and so these spots are a little bit high. Once I've got that done, I can then come along with my dovetail spotting piece and do the insides here. Now I think apart from the fact that they've got paint smeared all over them, I think these would be reasonably right, because that would have been cut with a 60-degree dovetail cutter, so there might be a little bit of cleaning up required, but I think most of it will be, you know, quite satisfactory. You do this from the, I guess, the easy to the hard, or the easy to the less easy, and so scraping these two surfaces in was easy. That was on the surface plate, and so I could just scrape those, and provided I had a uniform sort of cover, I knew that was flat. Doing these ones here, I had to do flat, but I also had to make sure that they were co-planar, right? So they were all in the same plane. It's pointless having one that's flat like that and the other one that's flat like that, because you'll only get edge contact where it's sliding. And then to do this one, or these two, was a combination. I used that to make sure the surfaces were flat and co-planar, but I also made up this dovetail arrangement to ensure that they were actually flat as along the whole length, rather than just sort of flat locally. It was a good thing I did that, because by just using this, I think I would have dished this. Okay, now making this, as you would have seen, similar sort of thing. Surface plate on that one, that's the largest surface. Get that flat, then scrape this to get this at the 60-degree angle to that. And I'll use the same technique that I used to get these flat onto that surface there, to make sure that those two surfaces are co-planar. All right. So where am I up to? Well, I've got these two flat and coplanar. I've used the dovetail to scrape that surface there, and that's now flat. The problem becomes I now need to scrape this surface, so that is at 60 degrees, so I'll use this again. But the other thing that has to happen is that these two surfaces have to be, the line of intersection of these two surfaces and these two surfaces has to be parallel. So I've got some dowels, and I need to measure that from there and then across at this end. Now I've already done that, and there's 0.1 of a millimetre difference. So using this side as my my primary side, I now need to scrape that. But I also need to hook off a little bit of material from here as well. So I need to scrape deeper on this side while trying to get that angle. So that's the next challenge. This surface is not necessarily flat or parallel, sorry, with the surface of the base. So one stage I'm going to put that up on some parallels, and I'm going to skim that off and just make sure that that is flat. And with the table on the top, I'll have to do something similar, I dare say. And that'll be that done. I'm also going to take the corners off, because when I have this sitting on a rotary table, which is where it's eventually going to go, I don't want corners sticking out. They get in the way of things. So that's that. However, there is one more thing that I do have to do. One critical part of this is this surface at 90 degrees to that surface? And so what I need to do now is just do a check on that. Before I do my XY check, I just thought I'd better make sure that the base is parallel to the scraped surfaces. I've put some parallels under the scraped surfaces, and measuring, I started here, I'm minus 0.14 there, and I'm plus 0.27 there. So what's that? Close to 4.41 of a millimetre. So it's pretty pointless me doing anything, putting all the work into scraping if the base isn't parallel. So I'm going to get a cutter. I'm just going to run round that and try and clean that up a little bit. Longer term viewers of the channel will realise that this is a universal mill, which means the table can swivel back and forth. Now, for me to check the XY of the little table, I need to make sure that my X and my Y axis are square. So what I've done is I've set up this block, I've checked that with a square, and I've run a dial indicator in, so this is trammed in, so this is parallel with the direction of the X travel. I then put that on the side and run the Y in and out, and that's now parallel to the Y. So because that's square and I've got parallel that way and parallel that way, it means that my X and Y axis are square. But now I've established that, I can do a little bit of work. I can now tram the base onto here and make sure that's parallel with the Y, and then I can attach the cross piece on there and check that and see that that is perpendicular to. The base has now been machined, so it's parallel with the scraped ways. And while I was there, I also got my big wall-halter boring head out and took the corners off. I've got several boring heads, and that one I use for, you know, big stuff and castings, that sort of stuff. I've now clamped the intermediate part onto the base. It's up tight. That's a new gib strip. Future Michael was very kind to send that back to me, so I'm using that. I would like to use a bit of round, but I haven't got one the right size, so I'm using a parallel, and that'll do me all right. It's just clearing the as cast section there, but as you can see, running the dial across from here to here, I've got about 0.25 of a millimetre, so a quarter of a millimetre, what's that, 10 thou worth of misalignment here, so I need to work out what to do with that. I'm not sure whether I should run a cutter down there or run a cutter down here and just clean that up, or whether I should just scrape it. I think I'll probably try the cutter method, just because, you know, 10 thou is a reasonable amount to take out. So anyway, that's where I'm going to leave you, because all the rest of it is pretty much a repetition of what I've done here. But thanks for watching, and we'll see you for the next one.